So in the last video, I talked a little bit about planes, and so I want to talk about them a little more. So let's draw my axes, x, y, z. So if you imagine the set of all numbers so that z equals 0, so you're starting here, but everything on the x-axis has z equals 0, and everything on the y-axis has z equals 0. But so then what you get is you get an infinite plane, the one that we saw when we looked down from the top of it. And this plane is the graph of the equation z equals 0. And this plane is called the xy plane. You'll notice that another way of thinking about this plane is it's the unique plane that contains the x and y axes, and we'll talk a little bit more about that later. But in addition to the xy plane, there are two other planes that sort of have special names that stand out. And so I'm going to draw some axes as I do. X, Y, Z. So suppose I set y equals 0. Well, it stands to reason I get the xz plane. And sure enough, if y is 0, that's true on the x-axis and it's true on the z-axis. So you can imagine an infinite plane that sort of extends infinitely along the x-axis and along the z-axis. And since I'm doing it for completeness' sake, x, y, well, let's try to actually make the z line go through the origin, z-axis. So now, if I set, so actually make that look like the letter y. Let me set x equal to 0, and so then I get what's called the yz plane. As always, there's sort of a convention here that when we name several variables, we try to stick to alphabetical order for whatever reason. So x is 0 on the z-axis and on the y-axis. So again, I get this sort of infinite plane, and so this rectangle I'm drawing is just a little tiny portion of it. So those are the sort of three big planes. But any equation of the form a single variable has a constant value, try that again, x, y, z, as long as a given variable has a constant value, you're going to get a plane. So, for example, if I try z equals 3, so I can imagine a line up here that is parallel, and imagine this as above the x-axis. And similarly, there's a line parallel and above the y-axis, and so x varies for whatever, z is constantly 3, y is 0 in this line, and similarly on this line that's parallel and sort of above the y-axis, it's just the y-axis translated up 3. So I imagine I've got that xy plane, but translated up 3. And I could do something similar for constant values of x or constant values of y. And just to demonstrate that, let me do one more. I'm going to draw x, I'm going to draw y, and I'm going to draw z. Let's say x is negative 2. And we're going to do this one in purple because I want to change it. So if x is negative 2, we're talking about this value of x right here. So imagine This is the y-axis shifted -2 in the x direction. And this is the z-axis shifted -2 in the x direction. And so then this here is the YZ plane shifted -2 in the x direction. So there's other sorts of planes that can exist, planes that are not parallel to any of these existing planes. And by parallel, I mean two planes are parallel if they never intersect. So all of these planes of the form x equals whatever. So I could do, just as a demonstration, this one's going to be yellow. If I did x equals 5, actually x is not going to be yellow because that is impossible to see. Let's try, this is some sort of weird mustard brown color, x equals 5. So here's x equals 5 on the x-axis, and I take the z-axis and the y-axis, and I get that plane right there, which is again the YZ plane translated +5 in the x direction. And these planes will never intersect, and one way you know they never intersect is that every point on the purple plane is of the form is of the form -2, y, z, and every point on the sort of mustard brown plane is the form 5, y, z. So the first coordinates don't match, so no point can ever be on both of these graphs. Now, that contrasts with if you're going to get real sick of me drawing the x, y, z axes, I assure you. So imagine, if you will, the, let's do the xz plane in red, and let's do the yz plane in green. And it's a little hard to see this, but if you sort of try to visualize this in your head, what you'll notice is that there is a single common line to both of these planes, and that is the z-axis. And so just like non-parallel lines are going to intersect at a point in 2 dimensions, non-parallel planes will intersect at a line. And we'll talk more about that later.